My name is Lawrence Rosenberg, and this is the Alpha Human Podcast. Before we begin today's episode, let me kick things off by stating that I am not a doctor, nor am I a medical or healthcare professional. The content of this podcast and any information, advice, opinions, or statements within it are not intended and are not to be used as a substitute for professional medical advice or for diagnosis or treatment. You should not disregard or delay in obtaining medical advice for any medical condition you may have, and you should seek the assistance of a healthcare professional for any such conditions. And always inform your doctor of any changes that you make or are thinking about making to your lifestyle. Okay, so as many of you know, I have chromophobe kidney cancer. And I've been dealing with this form of kidney cancer for well over 7 years now. And since I was first diagnosed, I've been on a ketogenic, mostly carnivore-based diet. At first, there was a ton of vegetables, actually, along with a lot of oil on top of animal proteins in my diet, that I then decided to cut out or cut back on all the vegetables I was eating. And really started focusing more on eating a lot more fatty meat, with the exception here and there of some nuts and some fruits. Okay, and that's been sporadic throughout the past 7+ years when I've included some nuts or I've included some fruit. And the fruit, by the way, it's just really been a bit more recently. Nevertheless, since that time, there has been 2 instances where the cancer actually had spread. So once, at one point, maybe 4 years in or 3.5 years in, the cancer had spread, from my kidney, where there's a tumor, small tumor, centrally located, as well as one on the, So there's one centrally located in the right kidney, the left kidney completely removed with the tumor that was on it originally. But there was always one in the center of the kidney. But about 3.5 years in, we saw that it had spread to the upper pole region of the right kidney, right? And, kind of as I assessed what I was doing differently when that happened, I noticed that I had been eating a lot more dairy and mostly cheese that I had started including in the diet. And then what had happened is that later on, I had included a few other things in the diet. I started including a couple of years ago some peanuts. Actually peanut butter. And I shouldn't say that because I've included peanuts here and there when I say nuts, peanuts, almonds, that kind of thing. And then I kind of stopped eating those nuts because they were kind of making me fat, even though it was in keeping with the ketogenic approach I was taking. And then I started getting back on the nuts, but specifically peanuts, specifically peanut butter, and really started making it a staple in my diet where I was eating it daily, right? And I was probably eating about 1/5 of a jar of peanut butter, 16-ounce jar of peanut butter. I was eating about 1/5 of it every day in pieces throughout the day. And I had also added a bit of collagen protein to my diet. And what I noticed was that about, a couple of years ago, or maybe 2.5 years ago, they saw a small nodule growing on my liver, and it kind of grew to be about almost 2 centimeters before we had surgery. I had surgery last August, and I had a piece of my liver cut out with that tumor. And so, in assessing again, hey, what was I doing differently, if anything, during that time from a nutritional perspective? And clearly, as I've just described to you, it was that I had added peanut butter and collagen to the diet. Now, in doing my research, could the cheese have affected the spread of the cancer from the central region to the outer region of my kidney? Could the peanut butter or the collagen had anything to do with the spread of the cancer to my liver. And it turns out that in my deep research, after the first tumor had spread, I had seen that there was evidence in studies for dairy, milk protein in particular, certain milk protein in particular, having a direct effect on metastasis. That's the spread of cancer. And I also found after the last bout, when we first noticed that liver tumor, that peanuts, believe it or not, have an effect on cancer metastasis or the spread of cancer. And so, and what about the collagen protein, right? So, the collagen protein is rich in a certain type of protein known as glycine. And so can glycine, like other amino acids, aid in the spread of cancer? It's more likely that glycine can influence the growth of a particular tumor if you're eating it in large quantities, because it is a building block. It does provide, that amino acid glycine does provide a building block. And so it could be argued that, glycine can, in large amounts can help a tumor grow. But that's not what this episode is about. What this episode is about is what I went through with respect to the spread of my cancer in 2 different instances, and what I had noticed I was doing different nutritionally, and what I found evidence-wise in support of the fact that perhaps a certain milk protein could have contributed to cancer metastasis and the spread of my cancer from the center of my kidney to the outer pole of the kidney, and that peanut butter, peanuts in particular, and a certain protein within peanuts could have had an effect on the metastasis of my cancer from the kidney to the liver. And so that's what we're going to get into. That's what we're going to get into today. We're not going to get into the milk protein issue. We're going to do that on the next episode of the Alpha Human podcast. On today's episode, we're going to focus on the issue as to peanuts and a specific protein in peanuts and how that could contribute to the metastasis of cancer. So let's get into it. Now, first, let me say this. If you don't have cancer, then consuming dairy or eating peanuts shouldn't be an issue. However, what I'm here to warn you about is that if you do have cancer, then eating milk products is most probably a terrible idea based on the research that I will share with you next week, or whenever probably 2 weeks from now, or maybe 3 weeks from now. I got to finish my research on it. I've already done the initial research. From what I found, it doesn't look good. But again, what we're here to talk about now is that consuming peanuts and or peanut butter as a regular part of your diet, if you have cancer, could potentially be very dangerous based on the studies we're going to discuss in this episode. Okay, so what is the problem with peanuts if you happen to have cancer? Well, peanuts contain a type of plant protein, in particular a lectin called peanut agglutinin, PNA for short. Lectins are proteins that bind to carbohydrates, and PNA has been widely studied for its ability to interact with a type of sugar called galactose. Galactose is a monosaccharide that can be synthesized in the body from glucose or from the metabolism of lactose, a disaccharide found in milk, right? So talking about milk and dairy. Nevertheless, galactose, right, can be synthesized from the metabolism of lactose, and it can be used in different biochemical pathways within the body. Now, a word on plant lectins in general. They are nasty substrates that can cause all sorts of problems for lots of people. Problematic plant lectins can be found in legumes. So you got your beans, your lentils, your chickpeas, your soybeans. Lectins can be found in grains, right? So you got wheat, barley, rye, oats, rice, corn. Everyone's heard, especially the wheat lectin, gluten. Everyone knows that gluten could be a big problem for a lot of people. Nightshade vegetables, so your tomatoes, your potatoes, your eggplants, your bell peppers. Lectins can be found in seeds and nuts. Obviously, we're here to talk about peanuts today, but they can also be found in sunflower seeds and almonds. Lectins can be found in cereals like rice. I think I already mentioned corn. So cereal grains, right? They can be found in pseudo grains like quinoa, right? Quinoa was, that was all the rage a few years ago. Lectins can be found in buckwheat. Lectins can be found in sweet potatoes and yams, so your tubers. And lectins can be found in fruits. So green bananas, right, is definitely one where you can get, a dose of lectins. And plant lectins can cause all sorts of problems for humans, including nutrient absorption interference. So certain lectins can interfere with the absorption of minerals and vitamins, such as iron, calcium, zinc, magnesium. Lectins can interfere with the absorption of vitamin D. That's a bad one, right? That you definitely don't want the absorption of vitamin D to be blocked. Vitamin B12. I mean, whether it's iron or zinc or magnesium, these are all essential. All of these minerals and vitamins are essential for the proper functioning of the human body. And lectins can interfere with that. Also, lectins can cause blood clotting. Some lectins can agglutinate. Sorry, let me repronounce that. Some lectins can agglutinate red blood cells. Agglutinate. Am I pronouncing that correctly? Excuse me. So when you agglutinate red blood cells, right, that's where your blood cells, your red blood cells can become clumpy, leading to blood clot formation. Not something you want if you happen to have any narrowing of the cardiovascular system, any narrowing of the arteries. The last thing you want is blood clot formation, right? But some lectins can do that. Lectins are also responsible for allergies and autoimmune reactions. So check this out. Some plant lectins can bind to the lining of the digestive tract and cause inflammation, irritation, and damage to the gut lining, and cause something called leaky gut, which you may have heard about. That's a condition where the intestinal lining becomes more permeable, allowing undigested food particles and toxins to pass into the bloodstream, triggering an immune response, because now the immune system sees things floating around the bloodstream, bacteria, toxins, food particles, things it shouldn't see in the bloodstream. And what happens? It kicks in an immune response that, could be you can have what is known over time as an autoimmune issue, leading to an autoimmune disease. In fact, some lectins, like peanut agglutinin, have been found to have the ability to mimic the actions of human lectins and bind to glycoproteins on cell surfaces. And this can lead to these immune responses, independent of leaky gut. And these immune responses, again, can trigger autoimmune conditions and autoimmune diseases. PNA specifically binds to the sugar molecule galactose beta 1,3-N galactosamine. Again, trying to pronounce some of this jargon here, right? Acetylgalactosamine, also known, right? So galactose beta 1,3-N acetylgalactosamine is also known as the T-antigen, or the TF antigen, which stands for the Thomsen-Friedenreich antigen, named for the Danish physicians Holger Thomsen and Torkild Friedenreich, who were the first to describe this blood group antigen back in 1929. So the T-antigen is a glycan, and a glycan is a complex sugar found on the surface of certain proteins called glycoproteins. And glycoproteins are proteins that have undergone glycosylation, a process where these glycans become attached to proteins. to form these glycoproteins, right? Unlike simple sugars or more common complex carbohydrates, glycans, including the T-antigen, have specific modifications that make them resistant to digestion. And then when bound as part of a glycoprotein, these glycans play essential roles in various biological processes, such as cell-to-cell recognition, cell-to-cell signaling, immune responses, cell adhesion, and protein folding. Protein folding, by the way, is a crucial process where a protein molecule adopts its specific shape or structure, determining its actual function within the human body. However, abnormal or dysregulated glycoproteins, so by the way, all of those processes are good things. However, when you have abnormal or dysregulated glycoproteins, they can contribute to disease development and progression. Okay, so with all of that said, let me read to you a finding from a study conducted back in 2014. I'm going to quote here. The appearance of peanut agglutinin, PNA for short, in the bloodstream after peanut consumption by cancer patients mimics the actions of endogenous TF-binding human galectin-3 and promotes disseminating tumor cell metastatic spread. Wow, that statement in and of itself should scare the shit out of you if you have cancer, as it did myself. I wish I would have read that before I started gorging on peanut butter. Nevertheless, that's according to a paper entitled Peanut Agglutinin Appearance in the Blood After Peanut Ingestion Mimics the Actions of Endogenous Galectin-3 to Promote Metastasis by Interaction with Cancer-Associated MUS1. That's a long title, guys, but that's the name of the paper. And what is MUS1? MUS1 or MUC1 is a transmembrane glycoprotein that is commonly expressed on the surface of epithelial cells and cancer cells. It plays a role in protecting and lubricating epithelial surfaces, as well as in cell signaling and cell adhesion. Now, aberrant glycosylation of MUS1 in cancer cells, glycosylation, which if I didn't say it before, let me clarify it now. Glycosylation is a process involving the addition of a sugar molecule to a protein or a lipid. And abnormal sugar modification, right? So abnormal glycosylation of MUS1 can result in the exposure of the T-antigen, making it accessible for binding to lectins such as peanut agglutinin, PNA. And when that happens, the modified form of MUS1 protein with exposed TF antigen is known as TF MUS1, right? Thomson-Frieden-like MUS1. So PNA in the blood after peanut ingestion mimics the actions of endogenous galectin-3. Again, what is endogenous? Endogenous is right inside the body, as opposed to bringing in a lectin from outside the body, like bringing in PNA in the body, which will have our human lectins produced within the body, endogenous. So endogenous meaning produced endogenously or internally inside the body, as opposed to bringing it in externally. And PNA in the blood after peanut ingestion mimics the actions of endogenous galectin-3 and promotes cancer cell metastatic spread. So the question is, first, let's, what is galectin-3 besides being, this human lectin? Let's dive into it a little bit more. So galectin-3, also known as GAL3 for short, is a human or mammalian lectin. It's a multifunctional carbohydrate binding protein that is found in various tissues and organs within the human body. GAL3 has various beneficial roles in the body. So GAL3 isn't necessarily a bad thing, especially if you don't have cancer, especially if, there's no TF antigen hanging out on cancer cells that could bind to GAL3, right? So typically, GAL3 can be a very good thing for you. It's involved in immune response regulation. It's involved in tissue repair and wound healing. So when you hear cell adhesion, that's a good thing because you want cells to stick to each other when you're looking to close up a wound. Host defense against pathogens. So galectin-3 is involved in that. It's involved in the regulation of the extracellular matrix. It's involved in tissue differentiation. So all positive things, unless GAL3 is overexpressing itself or it's dysregulated because you have a certain disease condition. In those cases, having lots of GAL3 floating around the body can have negative consequences, including fibrosis. So GAL3 plays a role in tissue fibrosis or tissue scarring, and it does it by promoting the activation and proliferation of something called fibroblasts, as well as the deposition of the extracellular matrix components, right? So when you have fibrosis by promoting the activation and proliferation of fibroblasts, or because of the deposition of these fibroblasts within the extracellular matrix complex, you're going to have problems. You're going to have the overexpression of GAL3 contributing to excessive tissue scarring and organ dysfunction, such as renal fibrosis or liver fibrosis. For example, GAL3 has been implicated in cardiac fibrosis, which is a condition characterized by excessive accumulation of fibrous connective tissue in the heart. Increased expression and activation of GAL3 contribute to the progression of cardiac fibrosis by promoting fibroblast proliferation, collagen deposition, inflammation, and adverse remodeling of the heart. Dysregulated GAL3 expression is also implicated in chronic inflammatory conditions such as rheumatoid arthritis, inflammatory bowel disease, atherosclerosis. It can contribute to immune cell activation, cytokine production, tissue damage, and impaired regulation of GAL3 has been linked to neuroinflammation and neurodegenerative diseases, including Alzheimer's disease and Parkinson's disease. And it can contribute to neuroinflammatory responses and neuronal damage. Additionally, GAL3 has also been linked to viral attachment, suggesting that this lectin, galectin-3, promotes viral entry into host cells and infection. And while GAL3's promotion to cell-to-cell adhesion is a good thing for wound healing and tissue repair, its overexpression leads to increased tumor growth due to cancer cell adhesion, as well as invasion, migration, metastasis, angiogenesis, and immune evasion in several types of cancer. So how does that work? So let's look at the steps involved with how GAL3 overexpression promotes the spread of cancer. So number one, GAL3 circulating in the blood will bind specifically to the T-antigen on the surface of cancer cells. And this interaction is kind of like a lock and a key mechanism, where GAL3 acts as the key that fits into the T-antigen lock. And then the binding of GAL3 to the T-antigen provides a bridge between the cancer cell and the extracellular matrix or endothelial cells. And this bridge strengthens the adhesion between cancer cells and their surrounding environment. So enhanced adhesion allows cancer cells to firmly attach to the extracellular matrix or to endothelial cells, providing stability and support for subsequent steps. Like with stronger adhesion, the cancer cells can exert certain mechanical forces and start migrating through the tissues, guided by the cues provided by the extracellular matrix or endothelial cells. And then as those cancer cells start to migrate, they can invade surrounding tissues, breaking down barriers and infiltrating into nearby blood vessels or lymphatic vessels. And once inside the blood vessels or lymphatic vessels, cancer cells can travel through the circulatory or lymphatic system to distant organs or tissues, leading to the formation of secondary tumors at these new sites. And so PNA mimics GAL3, right? And so if GAL3, when overexpressed, can have such a disastrous effect for cancer patients, imagine now, right? Imagine now, kind of bringing a GAL3 mimicker into the body when you have cancer, right? In the form of PNA, in the form of peanut agglutinin, because you're eating lots of peanuts. You think it's a good thing, right? You're trying to keep your protein up. You're trying to, you're trying to bring in some form of nutrient dense food into your diet as a staple of your diet to kind of get all the good things you think you're going to get from peanuts. But what you don't realize is that you're bringing in something that mimics GAL3 when it overexpresses, right? Because if GAL3 wasn't overexpressing in the blood and you did have cancer, you kind of be just dealing with the cancer that you have. And then you might have surgery, or you might have some form of treatment to kill the tumor. And if there was no room for metastasis at that point, and you weren't overexpressing GAL3, you'd kind of hope you were okay. But then what you end up doing is you start introducing PNA into the system exogenously, and it starts mimicking lots of GAL3 floating around the bloodstream, right? And this PNA is such a good mimicker of GAL3, and it so effectively binds to the T-antigen like GAL3 that researchers actually use it to detect and analyze the presence of the T-antigen on cancer cells through techniques such as immunohistochemistry and flow cytometry. And this helps in characterizing the glycosylation patterns of cancer cells and understanding their roles in tumor biology, including cell adhesion, evasion, and metastasis. Yet the very same thing that makes PNA such a good tool for investigating these carbohydrate structures on the surface of cancer cells, that being its strong binding affinity for the T-antigen, also makes it particularly dangerous with respect to the metastasis of those cancers, right? So, I mean, especially because of its role in cell adhesion and signaling processes. So, I would think you'd want to stay away from the damn thing if you happen to have cancer. I certainly do. And this study here is giving you a reason to stay away from peanuts and PNA. Now, here's the thing, right? Like under normal because you might be thinking, well, shit, maybe I should just give up peanuts, altogether. But here's the thing: under normal circumstances, the T-antigen on glycoproteins is actually hidden or masked, right? So the lectins like GAL3 floating around your body don't see it, right? So it's not readily accessible to bind with GAL3 if you're healthy and under normal conditions. And this is because the glycans on glycoproteins have specific modifications that prevent GAL3 from being recognized, such that they can't bind to these glycans like the T-antigen. However, when there is abnormal glycosylation, which can happen when there are errors or disruptions in the normal cellular glycosylation process, such as is the case in cancer or autoimmune disease or genetic mutations, then it can lead to the exposure, the unmasking of the T-antigen. And when the T-antigen is exposed, it becomes accessible for binding to lectins like peanut agglutinin, which mimic the actions of GAL3. And then the binding of PNA can lead to enhanced cancer cell adhesion, right? So under normal, right? Like even if you had some GAL3 floating around the body, and it saw the T-antigen because it was on a certain type of protein like mus1, which was already dysregulated, revealing the T-antigen on the cancer cell, and GAL3 binds to it. Hey, even if GAL3 is not flooding the system and it's not overexpressed, and you're getting a little bit of binding here and there, maybe that's not a big deal. But right? The thing is, what happens is that when when GAL3 is overexpressed, right, or when PNA is mimicking it, right, which mimics the overexpression, what you then have is enhanced cancer cell adhesion, right? That's the problem. The binding, right, of PNA, the binding of when you have lots of GAL3 in the blood, that can enhance the adhesion and also contribute to invasion, migration, metastasis, as I said before, angiogenesis, immune evasion, contributing to disease development and progression. So with that said, let's get back to the study that we were discussing, the 2014 study. I'm going to quote, right? So hold on, let me just take a sip of water here. Okay, so galectin-3, quote, galectin-3 is commonly overexpressed in cancer and facilitates cancer progression and metastasis by interaction with various galactoside-terminated cell surface glycans. The levels of circulating galectin-3 is increased, get this, people, it's increased up to 31-fold in the bloodstream of cancer patients. And patients with metastasis have higher levels of circulating galectin-3 than those with only localized tumors. Recent studies by us in this group, which, by the way, I believe the study was conducted at the University of Liverpool. So the group's at the University of Liverpool. Recent studies by this group and others have shown that the increased circulation of galectin-3 in cancer cells is an important promoter of cancer cell metastatic spread. Galectin-3 binds to the TF-antigen on the large transmembrane mucin protein mus1, which is itself commonly overexpressed by cancer cells. It should also be mentioned that lengthy presence of PNA in the circulation after peanut ingestion by cancer patients may, like circulating galectin-3, interact with the blood vascular endothelium and induce changes in the endothelium that might contribute to metastasis. Thence, the appearance of PNA in the bloodstream after peanut consumption by cancer patients mimics the actions of endogenous TF-binding human galectin-3 and promotes disseminating tumor cell metastatic spread. So there it is, people. PNA in the blood can look to the body like an overexpression of GAL3, which is known to be increased in cancer patients with metastasis. And in cases where cancer has not spread and GAL3 levels are normal, the T-antigen may still be exposed on glycoproteins associated with the cancer. But as I said before, the chances of metastasis would probably be low due to the lack of GAL3 activity. So maybe you have a little bit, as I said. However, you start pumping in peanuts and PNA from peanut consumption, and that could potentially confuse the body and create an environment similar to one with metastatic activity, even if the cancer has not actually spread or is not showing, the activity that would lead to the spread. And therein, you would be promoting, by putting in all that PNA, you may be promoting the dissemination of tumor cells and potentially contributing to the spread of your cancer. So imagine, like, I'm pumping in all this peanut butter, as I said, right? Like 1/5 of a jar of peanut butter a day. I think I'm doing a good thing, right? I'm using the ketogenic diet, I'm getting this great nutritious food with good amount of protein, getting that in the diet. Little do I know, I'm pumping PNA throughout the bloodstream. And is that contributing to the cancer cells that I have, the chromophobe cancer cells, becoming stickier and then attaching itself to the endothelial cells and then, the extracellular matrix, and kind of promoting the invasion and the metastasis of those chromophobe cancer cells. Is that what made its way over to my liver? I don't know. Maybe it did. But as soon as I saw this study, man, that was it. Man, I dropped peanut butter immediately. Haven't had any peanut butter now in well over a year. So listen, that's a fucking wake-up call for me. But now, as if that weren't enough of a warning to anyone listening to this that might have cancer, fast forward from 2014 and the information I just quoted on galectin-3 and PNA, let's fast forward to 2021, because in 2021, this group published a new paper, right? And this one shows additional links between peanut agglutinin and cancer metastasis. The paper is entitled "Appearance of Peanut Agglutinin in the Blood Circulation After Peanut Ingestion Promotes Endothelial Secretion of Metastasis-Promoting Cytokines." So here we go. We got a brand new mechanism for you. So this study demonstrates that circulating peanut agglutinin, PNA, interacts with both micro and macrovascular endothelial cells, which are the cells lining the inner walls of the blood vessels, if I didn't say that before. And this interaction triggers the secretion of two cytokines, namely monocyte chemoattractant protein 1, MCP1 for short, or CCL2, and interleukin 6, IL-6 for short. And these two are triggered by, these two cytokines are secreted by the endothelial cells. And when they're released, they happen to have an autocrine or paracrine effect, which simply means they act on the same cells or nearby cells, respectively. And the increased secretion of these cytokines, MCP1 and IL-6, leads to the upregulation of certain adhesion molecules, again with the adhesion, right? But it leads to the upregulation or the overexpression of certain adhesion molecules on the surface of endothelial cells, right? Those cells that are in the walls of your blood vessels. And these adhesion molecules include, so there are different types of adhesion molecules. They're known as integrins, or vascular cell adhesion molecules, VCAMs for short, and selectins. So integrins, by the way, are cell surface receptors involved in cell-to-cell and cell matrix interactions. VCAMs are specific adhesion molecules found on endothelial cells that facilitate the attachment of leukocytes, which are white blood cells, to the endothelium during inflammation. And selectins are a family of adhesion molecules that mediate the initial interaction between circulating cells and the endothelium. And the upregulation of these adhesion molecules promotes increased adhesion between tumor cells and endothelial cells, as well as the formation of endothelial tubules. And this enhanced adhesion and tubule formation are important steps in tumor cell metastasis, where tumor cells invade blood vessels and spread to distant sites within the body. So what this study found was that the binding of PNA to a melanoma cell adhesion protein produced by the MUS1-8 gene, known as MCAM, so it's a protein known as MCAM, or CD146, on the surface of endothelial cells happens to be mediated by N-linked glycans. And just to clarify, N-linked glycans are different from the T-antigen. So here we're talking about a mode of activity that involves a different type of glycan. However, so the T-antigen is what's known as an O-linked glycan, and then you got your N-linked glycans. The difference between those two, between N-linked and O-linked glycans, are mainly structural, right? in the end, they both affect similar biologic processes such as protein folding, cell recognition, what we talked about before, cell adhesion, immune regulation. Nevertheless, it turns out that according to the study, PNA binding to end-link glycans on the MCAM protein initiates a signaling pathway that induces the secretion of metastasis-promoting cytokines, MCP1 and IL-6 by the vascular endothelium. So while both of these studies involve PNA and its role in metastasis, they propose different mechanisms and target different cell types. So the first study demonstrates that peanut agglutinin, which structurally resembles Gal3, can bind to the T-antigen expressed by the mus1 protein on certain cancer cells. This binding enhances the adhesive properties of the cancer cells, enabling them to adhere to the endothelial cells and invade different tissues. In contrast to this, the second study focuses on PNA binding to endothelial cells themselves and the subsequent activation of signaling pathways that then lead to the secretion of metastasis-promoting cytokines, which further enhance endothelial tumor cell adhesion and angiogenesis. And given that elevated levels of Gal3 have been associated with numerous health concerns, not just cancer cell metastasis, right? Beyond avoiding PNA through heavy peanut or peanut butter consumption, what the hell can you do? Because you think to yourself, okay, you've got cancer, so you definitely now, after hearing this, maybe you're going to avoid eating peanuts, eating peanut butter, bringing in this peanut lectin. But what happens if you're doing that and Gal3 is overexpressed anyway, right? So you've got your initial tumor, you've got your initial cancer, but it's starting to show metastatic activity. Gal3 is being overexpressed. It's seeing the T-antigen on the proteins that are hanging out on your cancer cells, and it's connecting. And it's slowly but surely, or maybe very quickly, causing your cancer to become more invasive, stickier, more adhesive, right? And essentially helping to spread the cancer. What can you do then? In the one instance, if your cancer isn't showing metastatic activity, then God bless, you just avoid PNA and you're doing a good thing, right? Probably based on these studies. But if Gal3 is floating around anyway in your blood in high amounts, like in that study, 31-fold, and they found 31-fold increases in cancer patients of Gal3 circulating in the bloodstream, what the fuck do you do then? Well, turns out there are drugs that are being researched as Gal3 inhibitors, right? To block the lectin, the human version of the lectin, right, from connecting to the T-antigen on these glycoproteins that are on the cancer cells. But I'm not going to get into the research. I'm not going to get into the Gal3 inhibitors that are out there. Forget that. Here's what I am going to get into. Because if you've got an overexpression of Gal3 floating around the bloodstream, there actually looks like there happens to be some natural substances which could inhibit or affect Gal3. And so, without having to look into drugs, you actually have this natural substance known as modified citrus pectin, MCP for short, right, which appears to be very interesting in its effects on galectin-3. So MCP is a type of pectin derived from citrus fruits that have been investigated for its potential to inhibit Gal3 activity, and it has shown some promising results in preclinical studies by binding to Gal3 and blocking its interactions with cancer cells. And they've done a number of studies on the benefits of these pectins. So what I'm going to do is I'm going to give you the names of some of these studies. Hold on, let me take a sip of water. If you're interested in exploring this further, you can check out these studies. I will include them in the show notes, so you can have the links there, and you can do some research. But here's some of these studies. Number one, pectins from various sources inhibit galectin-3 related cardiac fibrosis. That's the title of one of these papers. Another paper, modified citrus pectin stops progression of liver fibrosis by inhibiting galectin-3 and inducing apoptosis of stellate cells. Man, that's powerful. Here's another one, modified citrus pectin inhibited bladder tumor growth through downregulation of galectin-3. Very strong. And in the study entitled Modified Citrus Pectin Anti-Metastatic Properties, One Bullet, Multiple Targets. I love the title of that study. The authors reported that commercially available fractionated pectin powder, FPP for short, induced apoptosis approximately 40-fold above non-treated cells in LNCAP and C4-2 prostate cancer cells. Wow. So that's definitely a study that you might want to check out. So there you go. There are some natural elements. You know, we did that podcast last time, which looked into natural substances that can potentially induce ferroptosis and kill cancer cells that are sensitive to iron-mediated cell death. But here, you know, given everything I just explained to you about PNA and galectin-3 and how scary that could be if you're showing cancer cell metastatic activity, or if you're flooding the body with PNA, it's interesting to know that there is a natural substance out there that in these studies are being shown to block galectin-3. So that's fascinating. That's positive. So it's awesome to know that there are natural substances out there that can help. But here's what I can tell you. I avoid peanut butter like the fucking plague, right? But it's also important to note that, you know, in full transparency, that the dose that was used in these studies to elicit the effect was a very specific dose. So it's important to note, number one, that peanut agglutinin accounts for about 0.15% of the weight of the common peanut, and it's highly resistant to heat, highly resistant to cooking and digestion, and it's rapidly detectable in the blood after peanut consumption. But with that in mind, the dosage used in the two studies that I mentioned here was about, after I did the math on it, sorry. Well, yeah, I had to do some math, but the studies mentioned between 200 and 250 grams of peanuts, which equals, so the only math I did here, just to be transparent, was to convert the grams to ounces, right? So 200 to 250 grams of peanuts equals 7 to 8.8 ounces, or roughly half a jar of peanut butter. Because I was consuming lots of peanut butter, right? In the run up to seeing that tumor in my liver. Now, here's the reality: most people aren't going to gorge themselves on a half a jar of peanut butter. I certainly wasn't. As I said, I was eating, what was it, 1/5 of a jar of peanut butter every day. So, you know, so maybe every 2.5 days, or right. So every, you know, by every third day, I consume that much of a dose, but not at one shot. Here's the thing, though, people. We don't know if a smaller amount would elicit the same effect, right? Because the study, I'm not sure the study and again, I'll take another look, but I'm not sure the study was really looking at smaller doses, and if in fact that was affecting the the same impact. So who the hell knows? Who the hell knows if it turns out that only 2 ounces will have the same effect? Why? Either way, why take the freaking chance? Again, if you don't have cancer, fine, no problem. But let me tell you, people, if you have cancer, then you've got to take extra steps. There are things you have to do. Okay. What do? Look, I've had a lot of time to think about cancer because I've been dealing with cancer for over 7 years. So I've had lots of some people don't have that much time. And so I thank Jesus Christ that I've been given this much time to contemplate and to do as much research as I've done. And that I've had the good fortune and the blessing to be able to hopefully communicate and do these podcasts and maybe give some direction and some hope and some solutions to people. But at the end of the day, I've had a lot of time to think about cancer and a lot of time to do things about it, which I really hope have had an impact. What have I done about it? I'll do a whole podcast on my entire protocol, but some of the things I've done is I've been on a 7-year plus ketogenic, and or carnivore style diet. I've done things like, for the most part, for most of the time, 1 meal a day. So intermittent fasting, where I'm fasting typically 24 hours a day. I've even done extended fasts. I've had month-long periods where I've done 3 days a week of fasting. And actually, in my case, if you listen to any of my other podcasts, that turned out to be a bad thing. Again, from my research, it turns out that fasting for extended periods of time and increasing autophagy, which is what happens when you fast for extended periods of time, while a good thing for some cancers and some tumors, because it could shrink those tumors, turns out that in other cancers, like my cancer, it turns out it could be producing more material for those cancer cells to consume and to grow, because it turns out that in my case, my cancer actually gets its nutrient supply in a different way than most cancers. So again, if you're interested in that, listen to one of the previous episodes I did. Nevertheless, I've done fasting, and to this day, I do 24-hour fast, which is essentially eating 1 meal a day. Now, with that said, that doesn't necessarily cause enough autophagy for there to be a problem. Okay, what else have I done? I've researched my ass off. I train. I work out every day. I work out. I practice certain types of meditation and prayer. I visualize healing my cancer, right? I give myself over to God and to Jesus Christ, my Lord and Savior, to empower me, to give me the strength to battle cancer, to fight cancer, right? To become healthy, to become stronger. And to God bless, to perhaps win, or at least win battles along the way. Because, with cancer, the way I view cancer, it's more like a 12-round boxing match. It's a win if you win a few rounds. It's a win if you learn how to rope-a-dope, right? And maybe even last 12 rounds with cancer. Maybe you don't fully resolve it, but maybe you're shucking and you're jiving and you're getting out of the way of some of the big roundhouse punches that cancer can give you. And then maybe, if you're lucky and you do your research and you get a great doctor and you ask all the right questions and you get the right therapy and you do the right things, maybe you give a knockout blow to cancer, right? So maybe you can knock cancer the fuck out as well. But one of the most important things you can do, besides prayer and besides embracing Jesus Christ, one of the most important things you can do is research your ass off. Why? Because by gaining knowledge and becoming empowered, and learning about your cancer and potential therapies, both natural and therapeutic, pharmaceutical. By truly understanding the strategies such that you can empower yourself to ask your doctors good questions, questions that they have to think about in order to answer, that also expose them and their expertise to you, such that you might decide, hey, maybe I should get a second opinion, like I've done. And I've brought other doctors onto my team to get their advice. In addition to my current cancer doctor, I have 2 cancer doctors that I work with, 2 oncologists. One came from a study that I read that was very powerful in my journey of gaining knowledge on not just my cancer, but potentially how to deal with my cancer should I need therapies. So far, I've just done surgeries to deal with them. But should I need therapies, right? It's important to do those studies. And in one of the studies, the theraptosis studies that I've talked about in my previous podcast, I came upon a brilliant oncologist who pioneered and or authored a study on how to kill chromophobe cancer cells, my kind of cancer, with theraptosis. I brought them onto the team. And by doing this research, it made me smart enough to ask the right questions so that I could go out and seek this other doctor. And this is why embracing knowledge gathering, embracing insight, embracing educating yourself and doing your own research. Look, I'm not a genius. I make mistakes. And I'm not a medical professional. I'm not a doctor by any stretch, which is why I give you the disclaimer at the very beginning. But if I can take the time to read and reread these studies so that I can understand them, if I can do it, so can you. And as I said, even if all that does is empower you to ask good questions of your doctors and maybe drive you to get second opinions, then you know what? It's all worth it. And so, yeah, another thing that I do is I wake up at somewhere between 3 and 3:30 in the morning, so that I can do my daily routine. And as part of that daily routine, spend 2 hours a day researching, right? So most days I'm researching anywhere between an hour and a half to 2 hours, most of the time 2 hours, in order to better understand cancer and my cancer and strategies for dealing with it. So if you look behind me and you see the logo, it says Victory Through Insight. That's the only way you're going to fucking win. That's the only way you're going to have a chance, right? Because if you're going to fight cancer or any disease, you're going to need insight, and you should get as much insight as is humanly possible. And so with that said, if you've stuck with me this long, because, hey, I know all the jargon and my reading through these studies and my reading through the research that I'm laying out for you, that I've put together for these podcasts, it could be sometimes maybe very boring, but hopefully I'm providing you with some value. That's my sincere hope. And with that said, victory through insight, praise Jesus Christ, and God bless you all. Have a great day. I'll see you next time.